Welcome to this presentation of Prime Ziggy. With Prime Ziggy, you will be able to create state-of-the-art web applications with minimal technical knowledge. Enjoy! With Lego bricks, there are many different building possibilities. The bricks stay the same, but the creations can be very different. Wouldn't it be nice if we could build the state-of-the-art web apps of Ziggy just as easy as we build with Lego bricks? But what on earth does Lego has to do with computers and software? In the early 90s, Gerry Bot, the architect of Prime Ziggy, worked in Palo Alto, better known as Silicon Valley. He worked together with colleagues from the Stanford University on an expert shell which was being used to manufacture knowledge-intensive apps for financial institutions and banks all over the world. The Lego building system fascinated Gerry and his colleagues. A simple and very effective click system with which you could make all kinds of possible creations. The ideal foundation for the development of software. Just across Gerry Bot's office was the Stanford University. At the university there were, at that time still very unknown students, also inspired by Lego. Here you see a picture of the very first Google search engine. The server is surrounded by Lego bricks, and you can admire this piece of history at the Museum of the Stanford University. This proves that also the founders of Google were very fascinated by the Lego metaphor. Take a look at the colors. Do they look familiar? Many years after Google and Silicon Valley, Gerry still hadn't let go of the Lego metaphor. That is why the Lego building system was the starting point for the development of the software factory Prime Ziggy. Just like you click Lego bricks together, is it possible with Ziggy to build bricks and to link these together. The building bricks that we distinguish with Ziggy are being specified with editors. Keep in mind that the editors on its own are also manufactured with Ziggy. Every Ziggy building brick can be specified and, of course, adapted with its own editor. So every brick has its own editor. Let's go and have a look at a couple of screenshots from these editors. Here you see a screenshot of the interface class editor. We have chosen a menu option object model. After that, for the interface class button, and then all the interface classes who were stored in the repository were shown. As you can see, we have selected the div.bsr code interface class, which is shown in the detail pane of the master detail. This is a screen print of an interface attribute editor. When we are specifying Ziggy apps, we will be spending most of our time in this editor, because here there's a lot to specify per attribute. For example, not just the type, the name, but also validation constraints, behavior constraints, presentation, and so on. With Ziggy, we create state-of-the-art web apps. Web applications make use of a user interface. But what is a user interface exactly? We will answer this question in the next couple of slides. UI, user interface, carries out three basic functions. It shows information, it asks questions, and it has the possibility to have a call for action. A user interface is being implemented with user interface controls. Data tables also have an important role in the implementation. There are two types of user interface controls: basic controls and compound controls. Examples of basic controls are a drop-down combo box, a push button, a menu option. Compound controls are controls that are aggregated of other controls. UI basic controls are always single controls. All these single controls have different goals. For example, providing information, asking questions, or providing a call for action. If we take a look at the different types of information controls, we see a label, text, and pictures. There are many possibilities if we look at the controls that ask questions. For example, an input field where you enter values, a drop-down combo box where you select values, or an auto-suggest box. A call for action can be a menu item, a push button, a tile, and who knows what other kind of manifestations there will be in the future. UI compound controls always consist of multiple controls. You can see it as an aggregation, or, to get back to the Lego metaphor, as various bricks that are clicked together. Here you see 4 compound controls. The biggest compound control is a page. A page generally fills the entire browser canvas. Then we see an area, colored in red, because an area is not a real brick, but other bricks refer to an area. Or you could say, in the bricks, the area is an attribute. Then we see a panel and a pane. In the pane, the basic controls are assembled into a pane, a unity. One or several panes can be clicked on a panel, and one or several panels can be clicked on a page. Here you see, indicated in a red rectangle, what a page covers in the browser. In this case, the entire canvas. A page is being divided into smaller rectangles. These smaller rectangles are called areas. So, a page always has different areas. In these areas, you can load panels. Here we see, on the right in a red rectangle, Area 0. Area 0 always contains the toolbox. This toolbox offers many different standard functionalities that can be used by the Ziggy applications. In this screenshot, left on the top, you see Area 1. Generally, this is where the logo and the company name will be displayed. We find Area 2 on the top of the page, between Area 1 and Area 0. Generally, this is where the main menu and, in some cases, the only menu is shown. In Area 3, there is room for a submenu. Not all applications have this, but in this case, a submenu is a possibility. And the last area, Area 4. The main area. In this area, the application panels are being loaded. And now, back to the Lego analogy. You can click Lego bricks together and separate them again. Quite easy. Because of this building system, you can create, with just a few bricks, an infinite number of creations. That is the big success of Lego. Ziggy bricks need to be put together as well. Only not by clicking them on each other, but by referencing. Here you see an example of referencing. A Ziggy page refers to a panel list, and a panel list refers to panels. This is another example. A panel refers to a pane list, and every entry in the pane list refers to a pane. And now, the example of the button pane. A button pane refers to a button list, and the button list then refers, in every line of the list, to a button. With that, you place buttons on button lists and button lists on button panes. Obviously, a button pane is being placed on a button panel, which is shown on the page. Ziggy and patterns. You can see patterns as building instructions, like this Lego example. Every building step is explained, so you will be able to put the entire creation together. The most applied pattern in Ziggy is, by far, the master detail. A master detail pattern shows a data table with a master view and a detail view. Let's take a look at an applied master detail pattern in action. In this lesson, we will have a look at the most applied pattern in the Ziggy application, the master detail. The master detail always represents a table and shows the different records in the table. If we open a random table, for example an interface class table, in this case a Ziggy building brick, then we see that all the records of this table are shown instantly. The table that is shown here represents the master data, and if we select a random line, in this case the first one, we see the detail section. This detail section shows more fields than the data table, as you can see above. When we select another line, we see that the content of the fields of the selected line is shown. This is the basic principle, the pattern of the master detail, which is being used frequently within Ziggy. A Ziggy data table can be specified in two different ways: as a prime generic table or as an interface class with interface attributes and methods. Data tables, and also Ziggy data tables, are being stored in a database or in a prime generic table, which means it is stored in a database but in a generic way, or it is stored with the help of a service. These are the three possibilities to persistently store a table. A data table within Ziggy is always presented as a master detail pane, and the pane has, as you have seen before, a table with a master view and a detail view. The master view can be shown without the detail view, and, in some cases, the detail view can be shown on its own as well, that is, without the master view. Ziggy patterns always relate to panels. There are patterns remaining within one panel, patterns who use two panels, and there are even patterns who use three panels. Here you see an overview of all the patterns that remain within one panel. Let's have a look at some of these patterns in action. First, we log in to an application. We want to get a new car insurance. We see that there is only one question being asked: the area where the car insurance should be. We select Curaçao and directly see a second drop-down combo box occur with currency for the policy. This is an example of a cascading search. The first two fields will link together, and only if we fill out the area, we know out of which currency we can choose. When we go for a smaller island, Bonaire for example, we see that with regard to the currency there is no longer a choice. So, area and currency behave like a cascading search. We continue with the second cascading search, which relates to table car brands. We have to make a choice between different car brands. We choose BMW. All the available models appear and we choose the 2800 series. There is only a standard edition, so we automatically continue with the next pattern, a lookup. We have picked up production year, fuel, body type, sports car and acquisition in the model. The table lookup knows that there is no sports car edition of the BMW 2800 series. That is why this question is already filled out with no. The same goes for the acquisition, that has been picked up from the table and is shown automatically. In this presentation, we have looked at an example of different patterns. We looked at the cascading search and the table lookup. Both relate to only one panel. This is a panel of which we have said that it is not interesting to show various companies. That is why the master view is not shown. Only the detail view of the master detail is shown. There are two patterns that make use of two panels. First, the selection view, which has a source view and a target view. The second pattern is the relation view, which also has a source and a target view. In the next presentation, we will have a look at an example of a selection view. Before you see the dashboard of an application designed for a tour operator who offers cruises. The guests of these ships have, at the beginning or at the end of the tour, the opportunity to book an extra event in a hotel. In that hotel, guides and hosts need to be linked to shifts, and the shifts need to be linked to the events that take place in this specific hotel. So far, the explanation of this system. When we click on events, we directly see a selection screen of the selection view pattern. It shows that we can look up events, and it asks us to fill out selection criteria. If we don't fill out any selection criteria, we see that there are over 43 pages with all kinds of events. Quite hard to find a suitable event for you there. That is why we take the date as a selection criteria. September the 1st, 2014. The amount of events is immediately reduced. There are various locations where there are events at this date. And we also see that there are cruises where people have to get on or get off. If we change something in the selection criteria, which means we change something in the selection panel of the selection view, the current selection is no longer accurate and therefore will be directly removed from the screen. We filled out the Movenpick Hotel in Amsterdam as an extra selection criterion. If we now click on the button Find Events, we will see all the events that take place at the Movenpick Hotel at September the 1st in 2014. This is how a selection view works. In the next presentation, we will have a look on what we have to do to realize this pattern within Ziggy. Good observers already found out that all the examples so far are being presented as a single-page application. With Ziggy, we always make single-page applications. The Google Mail application is one of the first single-page applications that is being used on a big scale. A single-page application always sends one page to the browser. All the screen changes that are observed after that are not achieved by picking up a new page. With the development of Ziggy, you can use the Ziggy pyramid. This pyramid helps the business analyst during the entire creation process. The base of the Ziggy pyramid represents the what. We have a quadrilateral, which means that the bottom is a square. There are 4 triangles that represent the object, model, the presentation, the behavior, and the persistence. The object model triangle is presented in 3 different layers. First, an interface class. Second, a generic table type. And third, an abstract interface relation. The idea behind the Ziggy pyramid is that all the bricks are being clicked on each other, layer by layer, to eventually get to a productive building. That is the reason we usually start with the object model and with specifying the interface classes. Only in the second stage, the second layer, we add the generic table types. And when that is done, we proceed to the third layer, the abstract interfaces. In the presentation triangle, we see panes, panels, and pages. Within the panes, there is also space for single controls, such as buttons and tiles. In the behavior triangle, we start with the process actions. After that, the validation constraints, and the third and last layer contains the behavior constraints. The process actions are the actions that are carried out if we have clicked on a button or menu. Validation constraints are the rules that are being used to restrict the content of the selected values. And behavior constraints are behavior rules that decide whether a certain field is shown or not and is edible or not. This could also relate to a panel or a pane. The last triangle is the persistency triangle. Here, the first layer is the data implementation, which means the implementation of a generic table or an interface class data table. We make sure that these are implemented and also that we save all the required data when it comes to persistency. Then, the building bricks can be clicked together in modules, and the modules can be clicked on packages. Good to know, Ziggy only works with pages, panels, and data tables, which means only these can be selected within a module. It is possible to deliver several modules within one package, so you have, with just one click, all the acquired components for a production. This was the presentation on the fundamental building bricks of Prime Ziggy. We would like to invite you for the Prime Ziggy training, where you learn how to make apps with Ziggy. Thank you for your attention, and we hope to see you again.